Now, before we look at applications of calculus, we want to have a look at our rules that we need to know. So, what must we be able to do before we actually apply the calculus? So, we need to be able to apply our rules here. So, we know how to differentiate different functions. So, if it's just a simple polynomial, x to the power of n comes nx to the power of n minus 1. We also need to remember our product rule. So, if we've got two functions that are multiplying, we take the derivative of the first function, multiply it by the second, plus the first one multiplied by the derivative of the second. Quotient rule, when we have two that we're dividing, we divide the numerator, multiply it by the denominator minus the derivative, the numerator minus times the derivative of the denominator, and over the denominator squared. So we've got to get that order correct. It's not so much as important in the product rule, much more important in the quotient rule, and the chain rule as well, where we've got a function to the power of something. So the function of a function rule, we need to differentiate it without affecting what's inside the bracket, but then multiply it multiplied by the derivative of the function. So you've got to remember these rules. So you don't want to be making errors when you're trying to apply the calculus with the actual calculus rules. So remember about that gradient of the tangent is to a curve is the same as the gradient of the curve of the point, and that's why we get our gradients. We also have to remember parallel lines have the same gradient, and the product of gradients of perpendicular lines is -1. We need to remember our index laws. So all these things are important. They all play a part in making sure we solve problems correctly. So looking at some questions involved in differentiating. So differentiating polynomials as we go through. So 3x cubed differentiates to 9x squared, minus 5x power of 6 equal to minus 30x to the power of 5. X differentiates to 1 and the 4 differentiates to 0. Remembering we have to manipulate to get our expressions in the form where we've got x to the power of a number. So, and then we can differentiate once we've got it in that form. So if we've got a fraction, there becomes a negative power. We look at the chain application of the chain rule in question 4. So the 7 comes down, bracket stays the same, to subtract 1 from the power and then multiply by 4, which is the derivative of 4x minus 7. So, and then clean it all up. So index laws are really important, as you can see, like square root of x has to be put in 8x minus 7 to the power of a half. So, and then you can differentiate. So be really careful, and then be careful with the subtraction of fractions. So the 1 over the square root of 5x plus 8 gives us the 5x squared plus 8 to the power of minus a half. And then we can differentiate. Again, be really careful. You're applying the chain rule. And these ones is product rule. So 8x plus 1 all cubed. Differentiate that first. Multiply it by the 5x minus 1 to the power of 4. And again, we're applying the chain rule when we differentiate 8x plus 1 to the power of 3. So then, plus the first function, and then times the derivative of the 5x minus 1 to the power of 4. And then we can, again, clean it up. This one we have to put it into fraction with the fractional indice, because it's the square root. But then it's one function times another, so we have to apply the product rule. Quotient rule here, so you can see the quotient rule being applied each time. Again, got to take care, differentiate the top, multiply by the bottom, minus the top one, multiplied by the derivative of the bottom, all over the denominator squared. So again, you can see the same process going on with the quotient rule. So all those three rules, where do we apply them, how do we apply them, and we make sure we do it right. Finding the derivative of the function of a value, all we need to do is derive the function. So 2x cubed derives to 6x squared, 5x squared derives to 10x, 3x derives to 3, and then sub in minus 2, and we can get a value. And that value, as we know, works out to be the gradient of the tangent at that point. So, and then we can go on and find the equation of the tangent to curves. So find the y is equal to x squared, we differentiate, we sub in x minus 2, we get our gradient, by subbing into the gradient function, and we get our y value by subbing it back into the function itself. So we can get our equation at the point minus 2, 4 by subbing into our point gradient form of our line. So that starts to make life a little bit easier as we go through there as well. So this time the tangent's parallel. We want to find the points where the tangent's parallel. So we're using the idea of our gradients and our gradient function and the derivative to be able to work out some problems. So if our tangent's parallel to this line, then it would have a gradient of 12. We can see that. It's in the form mx plus b. And if our gradient function for this curve is 3x squared, then where's our gradient going to be equal to 12? It would be equal to that at x is equal to plus or minus 2. And then we can get our y values by subbing it back into the equation there and getting the 0.22 and the point minus 2 minus 14. So it's just a manipulation of our ideas to suit the problem. And this time we've got to find the equation of tangents at the points where the curve cuts the x-axis. Well, we need to be able to solve that quadratic because it cuts the x-axis when y is equal to 0. So we get the values of 0 and 1 because it's not a hard quadratic to solve. We expand it out to get our derivative though. So x squared minus x gives us a derivative of 2x minus 1. And at x is equal to 0, we're able to get a gradient function by subbing it in of minus 1. So our equation there would be with the point 0, 0, and y is equal to minus x comes out as our gradient. When x is equal to 1, our gradient works out to be 1 as well. So we get y minus 0 is equal to 1 outside of it, x minus 1. And there's our gradient, our two tangents at the points where it cuts the x-axis of 0, 0 and 1, 0. Because it cuts the x-axis, it must be must have a y value of 0. So there's the applications that we've done so far. So a bit of a review. We need to know all that before we move on. You need to know it well before you move on to the applications of calculus, because this is all the nuts and bolts kind of stuff. And if you don't know this well, you're gonna struggle as you go through, because you don't want to have to worry about the mechanics here. You want to worry about the concepts we're going to do when we apply calculus to geometrical applications.